Hello everyone, in this video we will discuss the step 9, auto-tune the PID controller using the TIA portal fine-tuning function. From the previous video, we discussed how can we use the Ziegler-Nicholas method to calculate the gain, TI and TD three parameters. And then we use these parameters as an initial group PID parameters and then do the fine-tuning based on the process performance. We also have another method, as we know, in the TIA portal from the PID_compact, this function block, it has one integrated fine-tuning function, auto-tuning function inside this function block. In this video, we will mainly discuss how can we use this automatic tuning function inside this TIA portal. Alright, to implement the fine-tuning from this PID_compact in the TIA portal software, we need to click this button. And keep in mind, before we run the fine-tuning, your PID controller need to run in auto mode. And your process basically need to run around its operating point. And in this system, currently this process is working around 50 because this system is operating point that is 45. So firstly, we need to set a 45. Make the system working around its operating point. And currently, this PID controller that is under automatic mode. And we set a setting point. Okay. And before this fine-tuning, most of the time, we already got a rough PID parameters. That means your current PID parameters might work just fine, but cannot work perfectly. So using the PID auto-tuning, that can give you a better group PID parameters. Before we run the fine-tuning, we better write down the current PID parameters. In case the fine-tuning got an error or got a fail, we can still use this record PID parameters to recover those parameters. Okay, so when the system got its operating point and working stable, so we can start the fine-tuning. Okay, to start the fine-tuning, let's go to the fine-tuning here. Select the fine-tuning. And then click this start. And once you see this progress is changing, that means this fine-tuning is processing. As we can see, currently the system setting point that is 45. And this is the feedback from the process value, and this is the control signal. This process value can be seen from the PID instant DB. If we go to the PID instant DB, open DB editor, and go to the static. And from here, you will see one progress tag here. So this value shows 100% progress. Okay, this fine-tuning is processing. Roughly, we need to wait a couple minutes. During this time, your PID controller is controlled by this automatic process, and your process is still automatically controlled by this PID_compact, this function block, this controller. So keep in mind, when you're doing this fine-tuning, you must watch this process. And this is the first stage of this entire fine-tuning progress. We will see it almost reach 80%. And after this first stage, it will start to toggle the output and it will record the process change. I think the first stage, the system is preparing something behind. So we almost finished the first stage. And you will see when it's reaching this end, and it will start the second stage. Now it's start the second stage. We will see the changes on the output. So we will see currently the system is toggling this PID output. the green curve that is a process feedback, we will see this temperature process is changing. In the meantime, I will write down my current parameter. So my current parameter, that Kp is 70, and the Ti, that is 8 seconds, and the Td, that is 1.25. And after this fine-tuning, we will compare the system automatic fine-tuning results. So from this wheel, we will see this oscillation that's controlled by this automatic fine-tuning process. Our process value will have a little bit of oscillation here. Okay, we will see our setting point, that is 45, and this maximum and minimum, that is basically 2 or 3 centigrade. Because this whole progress takes a couple minutes on this stage 2. This system automatic toggling this system. So I speed up this video. It is doing 8 times speed. So it's easier for you to have an overall picture of this whole progress. You will see the system will give a different width of this control on and off. It's toggling with a different width. Okay, this second stage almost finished. We will see the control behavior will show a little bit different. So once it shows a highlight, that means this fine-tuning is finished. And after it's finished, we will see this online PID parameters, they are already changed by the system. And after this fine-tuning complete, so we need to click this button. That is upload the PID parameters. So this allows the system upload from the online controller to our offline this DB. And then let's go to the PID parameters. Okay, so the sample time is 1 second, and the proportion gain, that is 60. And the integral time, that is 14, and then derivative, that is 3.7. Okay, it shows online and offline not the same. So, and firstly, we can click this button. That is create a snapshot of a monitor value and accept the set point of this snapshot as a start values. And with this step, so our offline DB will get changed. So to match this offline and online, after this upload, we will compile this DB and download this DB again. Watch this parameter here. Because we did the upload, so when we download this DB, those parameters will not lose. And please watch this process. So now it shows the difference. After it's download, it will show the green. See, it shows green. That means our offline and online parameters, they all match. And the learned parameters are saved. Okay. We will see all those parameters are still here. And then let's test the process performance. So firstly, let's change to 50. In the meantime, let's compare the PID parameters from my side and the automatic fine-tuning parameter. So the Kp, currently that Kp, that is 60, is smaller than I said. And this integral, that is smaller than I said. this derivative that is bigger than my side. So, but basically, they are very close. And as we can see, this gain value is smaller than I said, so that's why this rising time is longer than I said before. So we can increase this parameter based on this value. For example, we can set to 70. And then let's decrease this set point to 45. And let's see this time. As we can see, after a couple times adjusting this right curve, that is output, PID output, so this process reached this set point. There's no overshoot here. Okay, let's set to 50 again. And let's go to the online monitoring here. I'm speeding up the video 3 times when it's doing this transition. Also, we'll see the right side of those parameters are backupped by the system. That was my parameters. Comparing with these 2 lines, they are very close. That means the system automatic fine-tuning that works. The left column, those PID parameters come from the system automatic fine-tuning, and right column that come from the Ziegler-Nicholas second method we discussed from the previous video. We calculate those PID parameters. They verified each other. That means this group PID parameters, they work for this process. Alright, that is this video. In this video, we mainly show how can we operate this TIA portal fine-tuning function. Alright, that is for today. Currently, this system we already get one group PID parameters, and this group PID parameters can work basically fine for this system. And in next video, I will mainly discuss for these 3 PID parameters, gain, integral, and derivative, when they increase or decrease, how they will change the PID control performance, and how they will impact the process changes. Okay, see you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.